Let's try one more example with graphing piecewise functions on the Cartesian plane. In this case, we're going to look at a function that has three different pieces. The first piece, anytime our x values are less than -1, we are going to graph a line, 2x minus 1, y equals 2x minus 1 is a line. It's a line with slope 2 and a y-intercept of -1. Anytime our x values are between -1 and 2, we're going to graph this, x squared minus 3, which is a parabola, right? X squared has that U-shaped minus 3. We'll see what that does to the graph too. So we're going to have a piece of a parabola in between -1 and 2. And anytime our x values are greater than 2, we are going to have a piece of a square root function. That was the little arm function. It looks like a Superman function. So when I go to sketch my Cartesian plane, which I'm going to do right now, what I'm going to do is I'm going to remind myself that the domain is going to switch up, and this time it's going to switch up in two different places rather than in one different place as it did before. So anytime my x values are to the left of -1, I'm going to draw a little dash line to remind myself of that. I'm going to have a line. So over here, I'm going to have a line. Anytime my x values are between -1 and 2, we're going to have a piece of a parabola. So I'll write a P here to remind myself we're going to have a parabola. And anytime my x values are greater than -2, we're going to have a piece of the square root function. So I'm just going to write the word square root there to remind myself. Now that we have an idea of what's going on each piece in the Cartesian plane, let's find some ordered pairs that we can map to these guys. So I'm going to start off with that first part of the function, f of x is equal to 2x minus 1, when my x values are less than -1. Okay, so my x values are less than -1, and my output for that function again is 2x minus 1. So I'm going to plug in -1, -2, -3. Let's create another t-chart. This is a t-chart for my next piece of the function with x squared minus 3. Now my x values are between -1 and 2. So my x values have to be between -1 and 2. So I'm going to try substituting in -1, 0, 1, and 2. And my output for that function was x squared minus 3. And my last t-chart that I want to create is anytime my x values are greater than 2. Put over here, so x is greater than 2. Let's try 2, 3, 4. I'm going to get a piece of the square root function. We'll call that the square root of x plus 2. And again, what this is going to do is give us some ordered pairs that are on the graph. Just make sure we maintain that shape. So let's try substituting in. We'll go back to, I'll put this guy over here. I think I did it in red. We'll go back to this guy first. I'm going to substitute in -1 for x. We have 2 times -1 minus 1. That gives us -3. When we put in -2, 2 times -2 minus 1, that gives us -5. When we put in -3, 2 times -3 minus 1, that gives us -7. So here are three ordered pairs. We know that it's a line. Y equals 2x minus 1 is a line. And let's graph these ordered pairs. Keeping in mind that at -1, we're going to have an open circle because it's strictly less than -1. It's not negative. It's not less than or equal to -1. So let's graph the ordered pair -1, 3. Let me put some values over here. I'll put some y values over here. When we go to graph the ordered pair -1, 3, and again leaving an open circle here because it's not equal to -1, it's strictly less than -1. Then we're going to go to -2, 5, which is right here. And then we're going to go to -3, 7, which would be right around here. I'm going to draw a line going in this direction. Oops, should have passed through that point. Oh, thank you. It's much nicer. And that's what that piece of the function looks like. Now let's go to our middle piece of the function. We'll do that one in green. When I input a -1, -1 squared minus 3. Well, -1 squared is 1, and 1 minus 3 is -2. 0 squared minus 3 is -3. 1 squared minus 3 will give us -2, and then 2 squared minus 3 will give us 1. So let's graph these ordered pairs. Both at -1 and at 2 they're both going to get closed circles there because it's equal to that value. So let's graph the ordered pair -1, -2. Here's -1, -2. Let's graph the ordered pair 0, -3. Here's 0, -3. Let's graph the ordered pair 1, -2. Here's 1, -2. And let's graph the ordered pair 2, 1. So here's the ordered pair 2, 1. Here is our beautiful piece of a parabola with closed circles at both endpoints. Again, closed circles because it's less than or equal to both these guys over here. Okay, so let's graph the square root function. Let's finish with that one. We'll do that one in blue. So anytime my x values are greater than 2, we're going to substitute in a 2. The square root of 2 plus 2, that's the same thing as saying the square root of 4, which is 2. Then we get the square root of 3 plus 2. So the square root of 3 plus 2, we're going to use our calculator to figure out what that's approximately equal to. The square root of 5 is approximately equal to 2.2. And then when we substitute in 4, the square root of 4 plus 2, that's the same thing as saying the square root of 6. And the square root of 6 is approximately equal to 2.4. So let's graph these 3 ordered pairs. Keeping in mind here again, at 2, we're going to have an open circle because it's not equal to 2. So let's graph the ordered pair 2, 2. Let's see, here's the ordered pair 2, 2, open circle. Let's graph the ordered pair 3, 2.2. So here's 3, here's a little bit higher, 2.2. Let's graph the ordered pair 4, 2.4. 4, 2.4 is over here. And we should see that shape, that kind of arm reaching out shape that we get when we have that square root function. So this is a good representation as to what this function f of x looks like.